chromosomal aberration. Means abnormal chromosomes, which is caused due to the modification in morphology of the chromosome. What is that? Modification in the morphology of chromosomes of the particular chromosome, okay, or chromosome or chromosomes. That means change in the structure. This is nothing but, we can say, change in the structure. Change in the structure of the chromosome. It alters the number or position of the existing gene in the chromosomes. Okay, it alters, changes. Alters means changes the number or position of existing genes. Genes in the chromosome. It causes the genes to be lost, or duplicated, lost or deleted, copied or duplicated, moved or rearranged. Change in the structure of chromosomes. Change in the structure of chromosomes occurs in mainly 4 ways. What are they? The deletion, the process of deletion, or the process of duplication, or by the process of inversion, or by the process of translocation. Deletion. Deletion means loss of segment. Deletion means when loss of a part or segment of chromosome. Which causes, what it causes? It leads to loss of gene. Okay, this is called deletion. The loss of part of segment of the chromosome which leads to the loss of gene is called deletion. Deletion is of two types. Deletion is of two types. That is terminal deletion and intercalary deletion. Terminal deletion or intercalary deletion. In terminal deletion, what happens? Let us see. Suppose this is the chromosome. Okay. Then what happens? Suppose here are the different genes are present. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, like this different genes are present. Then if terminal part is lost means, you see, suppose the terminal part 1 and 2 is lost, then left out is 3, 4, 5, 6, 7 and 8. Understood? This is the terminal deletion. And the example is, you can be the cry do chat. Chat syndrome. Due to the loss of or deletion of segment of short arm of fifth chromosome. Which chromosome? Of fifth. Fifth chromosome. This is S, fifth chromosome. This terminal deletion occurs generally due to the loss or deletion of short arm. Now what is intercalary? Let us say if this is the chromosome, normal chromosome, okay, then how the loss is done, where it is deleted, let us see. Suppose here are the genes 1, 2, 3, 4, 5, 6, 7, 8. Then this the portion segment in between the two ends. Here the terminal end, in between the two ends. This is one end, this is another end. Suppose this much part segment is lost. So what is left out? 1, 2, here the 5, 6, 7, 8. Okay. This is called intercalary deletion, where the part in between, which part is deleted? Segment in between two ends is lost. Now let us go discuss the duplication. Duplication means the duplication of the segment of chromosome. That means occurrence of a segment of the chromosome twice. Okay, here what happens, the lost segment of one chromosome is attached to its homologous chromosome. Let us see how it occurs. The broken segment of one chromosome is attached to its homologous chromosome. Okay, so how it occurs, let us say this is suppose one chromosome. Okay, its homologous chromosome is this one. Then what happens? Suppose this is A, B, C, D, E, F. So here also A, B, C, D, E, F. But these two are homologous to each other. Okay. Suppose a part is deleted from one chromosome and attached to another, so that the specific region is repeated. I am writing over here. A, B, C, D. Here A, B, C, D, E, F is there. A, B, C, D, E, F already it is there. Again the E, F is repeated. E, F is repeated. So this is the duplication of this E, F. The segment which is deleted from which arm, if it is attached to its homologous of the same arm, then it is called repeat or tandem. What it is called? This is called a repeat or tandem. Just remember this. Remember, the duplication is also known as addition. Okay, come to inversion. Here the broken segment of the chromosome is rejoined to the same chromosome in the inverse manner. The broken segment is rejoined with the same chromosome in inverse manner. Here distance between the genes is changed, the position of the genes are changed. Okay, position, distance, position, sequence, and distance between. Between the genes okay, is changed. How it happens? Okay, it occurs in two ways. Occurs in two ways. One is paracentric, another is pericentric. What are the two types? The paracentric and pericentric. Let us see, paracentric means what happens if what happens? Let us see. Suppose 1, 2, 3, 4 gene, 5, 6, 7, 8. Suppose in one arm, generally, in paracentric, it change the segment, inversion of the segment occurs in one arm. Suppose this this much segment, this segment is inverted and attached to the same. So what will happen? The sequence will change. 5, 6, 7, 8. Instead of 5, 6, 7, 8, it will become 5, 7, 6, 8. Okay. Here what happens? That it occurs in one arm. It does not include the centromere. Does not include the centromere. In pericentric, the centromere is included. Okay? In pericentric, the centromere is included. How it happens? Let us see. Suppose here 1, 2, 3, 4, 5, 6, 7, 8. These are the location of the genes, different genes. Okay, the corresponding alleles are also present. Telling yes, inversion occurs in the same chromosome, not in the homologous. So no confusion. Then what happens here? Suppose this segment including the centromere, it includes, inversion includes the inverted part, includes the centromere. Okay? So 1, 2, now 6, 5, and here this is reversed. 4, 3, 7, 8. This much is completely reversed, inverted. So 6, 5, then centromere is here, and 4, 3, 7, 8. So now you see the sequence of the genes, the position of the genes, the distance between the linked genes is different. Next, translocation, where a broken segment of one chromosome may join with the non-homologous chromosome. Okay, and it is of 3 types: simple translocation, interstitial or shift translocation, or reciprocal translocation, that is exchange in between the 2 non-homologous chromosomes. Simple translocation, see what happens. Suppose one, 2, 3, 4, 5, 6. This is one chromosome, and another is A, B, C, D, E, F. Then when one part is broken, then what happens? When one part is broken, this is simple one. Then what happens? One, 2, 3, 4, it remains. And where it is broken, and a broken part is attached to A, B, C, D, E, F, and this broken part is attached to non-homologous. It is, see, I have shown you differently. These 2 are non-homologous, and here 5, 6. This is called simple translocation. Okay, this is one kind, one type. Another type is that interstitial, or shift translocation. Remember, here the broken segment is separated and attached to the non-homologous chromosome. Okay, suppose this 1, 2, 3, 4, 5, 6, and when it is broken, the 1, 2, 3, 4 is remained. So what we have taken another non-homologous, maybe this is A, B, C, D, E, F. Now what happens? A, B, C, D, then in interstitial position, in between, in the middle, 5, 6, again EF is shifted. EF is shifted. That's why that because the broken this broken segment, where it is broken from here, it is broken. the broken segment is separated and joined in the middle. Okay, within the non-homologous chromosome, and that the part of the non-homologous is shifted. That's why it is called interstitial or shift translocation. Another is reciprocal translocation. Another is reciprocal translocation. In reciprocal translocation, what happens? Let us see. Suppose this is 1, 2, 3, 4, 5, 6. It is one chromosome. Another chromosome is non-homologous is A, B, C, D, E, F. And the exchange of the segment occurs in between the two non-homologous chromosomes. Then what may happen? Exchange. One, two, three, four. Here 5, 6 came. Five, 6. Now you see A, B, C, D, here E, F. So what happened? The exchange of the segment in between two non-homologous chromosomes occur. When exchange of segments of chromosome occurs in between homologous chromosome, it is called crossing over. When it occurs in between the non-homologous chromosome, that is in, as I told in reciprocal translocation, it is called illegal crossing over. One example is chronic myeloid leukemia, one type of blood cancer. It is caused due to the reciprocal translocation in between the 22nd and 9 chromosome. Okay? Let us summarize what we discussed so far. We discussed the chromosomal mutation occurs due to the change in number of chromosome or structure of chromosome. The number of chromosome that we discussed under the heading genometric mutation or heteroploidy, means where the ploidy, number of the ploidy changes, and that may be euploidy or aneuploidy. Euploidy where the set of chromosome, complete set of chromosome that changes. Number of complete set of chromosome changes. And in aneuploidy where the chromosome number of phase set or of all the set, the chromosome number is changed. Okay? As we discussed the monosomy, that is double monosomy or nolisomy, in case of in the hypoploidy, hypoaneuploidy, and in the aneuploidy another is hyperaneuploidy, that is trisomy, double trisomy, tetrasomy, like that. Okay, in the next session we will discuss the Mendelian disorder thalassemia. Okay.